Hello and welcome to another episode of AIM Fireside Chat. My name is Tausif Alam. I am editor at Analytics India magazine. Setting a bit of context for today's discussion, India's fintech industry has changed drastically in the past 10 years. While the fintech space was growing, data science boomed, overhauling the entire financial industry. The development in data science has also helped the fintech sector to create finance-based customized solutions and make them accessible to everyone. And the merger of data science and fintech has offered businesses solutions that help them build digital footprints, easing norms by creating less stringent credit services and offering liquidity solutions. When we are discussing data science and fintech, it's hard to miss one fintech company that has been an inventor and adopter of technology in every respect. I'm talking about Intuit. Intuit is the global financial technology platform that powers prosperity for the people and communities. With more than 100 million customers worldwide using products like TurboTax, Credit Karma, QuickBooks, and MailChimp, they believe that everyone should have the opportunity to prosper. Intuit never stops working to find new innovative ways to make that possible. In this discussion, we will learn more about how AI and data science is fueling innovation and solving the most pressing customer problems and delivering awesome experiences. For today's session, we have with us Vignesh Subrahmaniam. He is Principal Data Scientist at Intuit India. Together, we will discuss what it takes to be a data scientist and more around skilling and career growth. Vignesh comes with more than 12 years of research and development experience in machine learning and has been recognized as an innovator under 35 in India by MIT Technology Review for Self-Learning. On that note, let's watch our fireside chat with Vignesh.
Yeah, so I'll just take you a little bit about Intuit. So Intuit is almost 39 years old. Okay, so we call it it's a startup, even though it's 39 years old. And the company started when its founder Scott Cook watched his wife struggle to balance the family checkbook. Okay, a very simple thing. How do you balance a family checkbook so that you're not issuing checks when you don't have the amount in your bank balance? And it was done in a very complicated way using just pencil, pen and paper. This was like almost like 40 years back, right? And then he basically thought that there needs to be a better way to get this done. And so he created Quicken, which was the first time that, software was essentially used to help normal, common people, ordinary people who struggle to balance their checkbooks, people at home, who might not have all the tools to take care of the finances. So that's the first time that so that can we use software, to help normal people solve their difficult problems. Okay, so that's how Quicken was born. So if you look at Intuit has always been about using technology, right? Essentially digital tech, software tech, whatever you call it, to help people, normal people, ordinary people like you and me, to solve their difficult problems, especially in the space of, finances. Okay, yeah, but whether it's a small business looking at how do they manage their invoices? How do they manage their cash flow? How do they get paid as soon as possible, right? To, let's say, an individual normal person who has to look at what's the best credit card that he needs to basically subscribe to, what are the best loan offers that he might have, for which you have Credit Karma, or you want to look at a business that has to pay all its employees. You're looking at a small business, and then there are a lot of small businesses that exist, so almost I remember there was a statistic that said that I think 40% of the US economy, as well as, let's say, even the global economy, is basically driven by small businesses. Okay, so it's very important to basically empower them, so that it's funny when the small businesses thrive that the economy really thrives, right? And that's why, Intuit has a whole suite of products to basically help small businesses and individuals, to basically manage their finances, really well. And if you look at it, over the last 4 decades, Intuit has basically been at the forefront of using technology, to solve these problems. I think it started out with building out software in DOS, which was 40 years back. And right now, we are now a cloud native organization, so we build QuickBooks. All of our products are basically cloud native, and then we are leveraging the best of technology. And now we are moving towards, we are an AI-driven expert platform where we want to basically use AI and machine learning, to basically transform the way customers, small businesses and individuals, manage their personal finances and their business finances.
Perfect, perfect. So if you could talk briefly about your professional career and the work you do at Intuit.
Yeah. So I have almost like now 14 years of experience, working in machine learning and data science. In fact, when I joined, this career, it was basically data science as a term didn't even exist. Okay. Just to give you a background about myself, I've done my bachelor's, master's, and PhD in statistics from the Indian Statistical Institute. Fresh out of college, I joined GE Research almost in 2008. And at that time, there were very few people who were doing machine learning, in India. And the place where I joined was one of the few places that was doing machine learning. I think there was another lab in IBM that was doing machine learning. It was a very, very niche field, with very few people who were even aware of what this meant. So we were working on a lot of problems over there, looking at how do we use machine learning, statistical modeling, optimization, to solve problems, let's say in forecasting wind speeds better, can we basically make renewable energy more predictable, so that the energy that's produced can connect to the grid better. Can we look at, what is it that we can do to basically make healthcare more accessible and easier, so for example, if you get a CT scan or an MRI scan, is there a way for us to basically help radiologists, diagnose faster? So those are the kind of problems that we were working on. So very exciting stuff, that we had. And then what happened between 2008 to 2013 was essentially, cloud computing became extremely common, right? And before that, right, I mean, before 2013, almost all the models that we were building was on our desktop, laptop. I remember those were the days of MATLAB and SAS and so on. We were essentially doing all of our machine learning in MATLAB. Python was not even common that time. And then, with cloud computing coming in, it became very clear that, you have the ability to compute was no longer a constraint. Okay. Before we were like highly constrained by compute. And then with cloud computing coming in, compute was no longer a constraint. And that's when, we started, saying that how can we basically leverage the power of the cloud to do machine learning at scale. And that's what started to become a very interesting problem over there.
And I also wanted to discuss more about, the tech talents of India. India is one of the youngest population in the world. These people, set to drive a culture of innovation, entrepreneurship, diversity. So according to you, what is stopping companies from tapping into such diverse resources? Where do you think they lack guidance, skills, or development?
I think that we are doing a very good job. I mean, if you look at Intuit itself, we have a very strong and very talented data science team over here. We also have a large, very, very talented set of engineers who are very machine learning savvy. So, one of the things that we are doing at Intuit is basically to democratize AI and ML. Okay. So what this means is that we are moving towards a phase where, people can self-serve, AI models, directly. As long as they are aware of the basics of how machine learning algorithms work, so that's the way you truly democratize machine learning. So you don't need a PhD data scientist to basically be there all the time, to build a capability that uses machine learning. Okay, so you could have like engineers who are aware of the basic concepts of machine learning, build models for themselves, right? And that's kind of where the industry is going towards. And I think we are. I think Intuit at least provides like fantastic opportunities, for the diverse tech talent in India.
So what are some of the data science and analytics certification programs you offer in your organization?
So we have self-learning platforms such as Degreed and classroom sessions through tech learning at Intuit. So we have a tech learning team that curates, these wonderful sessions. Some of these are AWS workshops, Agile workshops, Spring Boot, AI, ML programs, big data, Python. The list is quite endless. So that's one thing that we do. Self-learning is very much a part of, of the learning culture within Intuit. We also care about the growth of our engineers as professionals, and we encourage our engineers to upskill themselves. For example, we partner with premier institutes such as BITS Pilani, where engineers can take up MTech in data science and grow their career and skills. We also push our engineers and scientists to innovate, publish papers on the craft. So craft is very important at Intuit, as every other company, we're a tech company, and file patents. We encourage them to be brand ambassadors, publish blogs, give technical talks. So all of these things basically help people to build the technical depth and also connect with the larger peer group of their technologists in the industry.
Cool. And how important is coding for data scientists, and why is it important at present?
So if I look at data science, right, or if I look at machine learning per se, I always say this. So machine learning is essentially like a tripod stool. Okay. So the three legs are a tripod stool. The first leg is basically statistics and probability. Okay. So that's the first leg. The second leg is applied mathematics, in particular optimization. Okay. And the third leg is computer science and programming. Okay. Now, to be a good data scientist, you need to be good at all three, because if you want a tripod stand to stand, you don't have one leg, you cannot stand, right? So if you look at it, so programming is something that's absolutely critical, for doing very good data science work, simply because if you look at it right now, we are using the science, the mathematics of data science, okay, to basically program and analyze data, right, and build models from data, right? So you can be very good at mathematics, but if you're not very good at programming, that's not helpful, right? So you need to be like really good at programming, and you need to be really good at the mathematics of machine learning. Does that answer your question?
Yes. Yeah. So I also wanted to know that, which languages would you suggest candidates learn, and why?
Yeah. I think the main lingua franca of machine learning right now is obviously Python. There's a lot of, I would also encourage people to learn Scala. Also learn a little bit of R, not necessarily, because there's a lot of advanced algorithms that basically are in R. So Python, Scala, I think those are the two main languages that you need to be really good at.
Going back to that previous question about maths and data scientists, can you give some examples as to which concepts they should be looking for?
Yeah. So if you look at machine learning as such, right, machine learning essentially has three main components. Okay. The first component is essentially about, if you look at machine learning, you're basically building a model that learns from data. So what exactly is learning? So learning is essentially all about, optimization. Okay. So when, for example, very simply put, if you're building a simple model that can classify a binary variable, into zeros or ones, you're basically, you have a set of inputs, and you want to basically say, can I build a function, can take the set of inputs and map it closest to the 0 or 1 over there, right, that you're trying to predict from a sample data set. Now, to do that, you need a concept of a loss function. Okay. So the first step is basically, how do you construct an objective function or a loss function that is meaningful, that is actually useful. Okay. And this is where a lot of concepts from statistics and probability come in. So in fact, every one of the loss functions that we use in machine learning have a very strong foundational basis in probability theory. So whether it's a cross entropy loss that we typically use, a likelihood function, all of these have like extraordinarily strong basis in statistics and probability. The second part of it is that once you have the objective function defined, how do you optimize it? Okay. Now, and this is where you need a lot of concepts in applied mathematics. So things like linear algebra, okay, very, very foundational. Real analysis, very foundational. Convex optimization, very foundational. Linear programming, very foundational. So you need to have the mathematical muscle to basically build and apply the right optimization algorithms, to solve for your problem. Okay. So that's really the second part of it. The third part of it is really around how do you implement these algorithms at scale and that are very efficient. Okay.
Hmm.
So
Okay.
it's one thing to kind of say that, hey, you know what, I have constructed a powerful optimization algorithm that can optimize the objective function that is very well defined, that can take into account all the class imbalance problems, all the the problems that I'm sure that many of the machine learning practitioners would be aware of. But then how do you basically do this in a manner that is efficient? Okay, and that is where the computer science concepts come in. How do you do parallelism? Right? How do you basically, is it possible for you to use distributed computing? Right? So those are all the concepts that come in over there.
And if you could talk about giving life lessons to data scientists, that what mantra do you suggest for data scientists to follow early in their careers?
Yeah, I think two things here. I think when I look at good data scientists, and I do get to see a lot of data scientists, I talk to them often, both within the company and obviously a lot of them interact with them outside the company. I think the key to being a very good data scientist, at least early on in your career, is to understand the bigger picture of what are you exactly trying to solve with the model that you're trying to build. Okay, so I'm a big fan of understanding the purpose of what you're doing. So many times you end up seeing, I end up seeing data scientists who will say, hey, you know what, I'm fitting a model using cost entropy loss. And I'm like, why the cost entropy loss? I mean, have you thought about if you minimize the cost entropy loss, how is it going to help the other person over there make their life easier if you make a prediction that's really good, right? And that's that last bit of connection that I sometimes feel lacking, when I look at data scientists, do the work. So I think having a strong connection between the work that they're doing and the actual problem that they're trying to solve for people and the world, I think that's something that's strong advice that I would give. The second part is that I always say is that spend time, okay, learning the mathematics of machine learning. Okay. It's very important. It's very important for you, for everybody who's a data scientist. I do this myself too. To go back and look at concepts in probability. For example, I sometimes just, whenever I feel bored, I'll go along and open up my book on convex optimization and read some concepts that I might have forgotten, and that helps, because when you read those concepts, you will suddenly find a trigger, a flash that comes in your mind, and you're like, you know what, I was never aware that this theorem or this result existed. There's a spark that comes back and says, can I go back and use that to build a new model, right? Or come up with a new way of optimizing a deep learning algorithm, right? So stay connected to the core mathematics of machine learning. That's very important. In what we do. I mean, all of us, I think if you look at a lot of machine learning scientists these days, they are very connected to the software and the computer science aspects of machine learning. But then where I see them slacking off is in connecting with the mathematics of machine learning. And I think that's very important too. So those are the two things that I would strongly encourage data scientists to do.
Perfect. And I also wanted to understand the career growth trajectory for data scientists at Intuit.
Yeah.
And yeah.
So if you look at the career growth of data scientists, I mean, obviously, in Intuit, we have a very strong, career path. We have a goal starting in from a data scientist, senior data scientist, staff, senior staff data scientist, principal, all the way to a distinguished data scientist. I mean, obviously, we have the full, a full career path that, allows data scientists to really grow and establish their credibility and as well as their presence, the branding that they can build for themselves. So that is definitely there. So that is really on a technical career path. And then we also have opportunities where, if at a later stage in their career, the data scientist wants to go along and say they want to lead teams of data scientists, we also have opportunities for that.
And so what are the qualities you look into, or the qualities which these data scientists must have from starting level to experience level as they grow in their career?
Yeah, I think the first step is basically, we call it like the most important criteria for a good data scientist at Intuit is they need to be really good at the craft. So when I say craft, they need to be really good at least two major aspects of machine learning. So it could be like be really good at mathematics, applied mathematics, or statistics, or operations research, or computer science. So out of these four things, they need to be really good at any two of them. Okay, so that is like very important. And then, as you obviously, if you're looking at a data scientist who is coming fresh from college, we expect them to be aware of the fundamentals of any of these two areas. And as we go higher up the scale to a principal and so on, they are expected to be somebody who's respected within the industry, within these areas. So that is really on the craft side of things. We have a lot of values that we also expect our data scientists to demonstrate. So for example, we expect them to demonstrate customer obsession. Can you really empathize with a customer problem? Can you basically put yourself in the feet of a customer, right? The shoes of a customer, and basically empathize with them and think about how what you're doing can help them help make their life easier. And that's very important for us. We also have a very strong need for bias to action. Intuit as a company is very focused on building things, building software that makes an impact. So we want a strong bias to action. We call that so that's very important. We also strongly believe in like being stronger together. So how do we leverage the best platform capabilities that Intuit is building? So Intuit is a platform company. We have an AI-driven expert platform. You don't need to build everything from scratch yourself. Are you going to be resourceful enough to use the best capabilities that Intuit's platform already offers to build a solution? More like systems engineering. So those are some of the things that we look at.
Perfect. So we talked in detail about data science and tech stuff. Now let's discuss work culture and team structure at Intuit. So if you can provide the comparison between data scientists' expectations versus reality in your organization.
I think so far in Intuit, I think for all the people that we have looked at, all the data scientists in our team that we have hired and who are doing really well. One of the reasons why they love working at Intuit is that there is little mismatch between what they were expecting and what they have. But I have seen that we have situations where data scientists can come, and though it's not happened as much in Intuit as I would, and I've seen this happen in maybe when I talk to people outside of Intuit, is that they come believing that they will do a lot of let's say mathematics. They'll publish a lot of papers, which is good. But then when they come in there, they suddenly realize that they have quarterly deliverables, that they need to do. So of course, you need to basically, if you're a good engineer, a good technologist, I always say this, that you need to basically build things, right? So it's very important to keep building things based upon the craft that you're very good at, right? Otherwise, there's no point in being called good, right? So that expectation is there. So of course, you can be very good at what you do, but you need to ground yourself and produce tangible impact. So that is obviously something that is very important. The other part of it is that there is a lot of innovation that happens in machine learning as such. So, and many data scientists sometimes are not aware of that. I mean, it's very rarely the case where you can go along and take a library from PyTorch or TensorFlow or sklearn, your favorite library, and just apply it, and everything looks good. That's rarely ever the case. So you need to really be really good at understanding the mathematics of how these algorithms work, so that you can go back, tweak them, modify them, and get the results that you are expecting, right? So I think those are two things that are very important.
If you can talk about the team structure then, and how is the data science team currently structured in your organization?
So the data science team is currently structured. So we have like essentially two roles, which are very important for us. I would say three roles. I'll talk about the third role. The first role is essentially a data scientist. Okay, so the expectation of a data scientist is that they are very good. They have a bias towards understanding the mathematics of machine learning, really well. And they're very good at programming, So, right, they're exceptional at understanding the mathematics of machine learning and are good at programming. And their main responsibility is to, really look at the data that we have, the rules that we have, and build foundational machine learning algorithms that can power experiences, So that's what they end up doing. The second role that we have is that of machine learning engineers, who are really software engineers with a bias towards understanding how machine learning models work, right? And then how do you deploy them at scale? How do you, for example, take a PyTorch model and basically, deploy it on GPU instances in a manner that saves the most amount of cost for the company, right? How do you basically have real-time inferencing for a deep learning model? So they work on like really hard engineering problems that are related to how do you make machine learning models available for our product teams to consume, right? So those are the two roles. We have a third role, which is essentially on machine learning infrastructure engineering, just really about understanding cloud infrastructure. How do you basically have the best infrastructure that is available that minimizes costs for the organization, so that our machine learning engineers and data scientists can have the best tools available, without getting a bomb for a bill.
Okay, perfect. If you can elaborate more on the work culture of your organization.
I think the work culture of organization is, I would say, the first thing I would say is fun. Okay, we have a lot of fun doing what we do. There's a lot of passion, in what we do, and there's a lot of learning. So I'm at least a very big fan of learning within the team. I always say that, that it's very important. I mean, for example, just to give you an example, every 2 weeks I connect with every member of my team, and then ask them like, what is it that they're learning? It could be anything. It could be a new paper that they're reading. It could be a new software package that they're exploring. What is it that they're learning? Can they present that to the broader team? So we have like small, what we call as like meet and eat kind of talks, where we have people presenting what they're learning over a nice lunch, that we have. So a strong culture of learning, a lot of passion about what we are doing, and more importantly, have a lot of fun as we do it. I think those are the three things that I will use to say the work culture of the organization.
So this work culture you're talking about, have you ever measured and seen that, what is the impact of this work culture on the overall organization or on the team?
Yeah. So if you look at the work culture, when you have a work culture that is really, like what I talked about, fun, passionate, and really around learning and innovation, one of the things that comes out is that, we have people who love to work in the company. Okay, who are like, they're not looking outside of the company, they just want to be an Intuit, right? So that's the first part of it. The second part of it is that we end up building models and deploying models at scale very quickly, so we can push the needle, we can generate massive amounts of financial impact for the company very quickly, when you have that passion, and customer empathy. That's the second thing. And the third thing is that, output, like, how many patents are we filing? How many conference publications are we doing? Right. So that's the third metric, that we look at.
Okay. And the final question, what advice would you give to young professionals who are entering the data science field based on your personal experience?
I would say, be open to learning, so, I mean, I know of data scientists who have, as I told you, right, data science is a field that's just newly been created. People have been doing machine learning for a lot more than before, data science was ever coined as a term. Never stop learning, always go back, and believe that, constantly keep learning, both on the programming and the software engineering side of things and the mathematics side of things. Both are equally important.
Perfect.
That's basically something that I would strongly encourage young professionals who are entering the field.
Perfect. Thank you, Vignesh, for holding such an informative session. I believe this fireside chat will help students and professionals who want to pursue careers in data science. And thank you once again for your time and valuable insights.
Yeah, Shyam. Yeah, thank you so much, Tausif. It was a pleasure talking to you.
Same here.